All right, so these examples that we have here, these are still like using and applying all of the same concepts that we have been doing with lines that are parallel and angles, okay? It's not that we're doing something totally different. It's just these examples on this sheet are a little more complicated than some of our previous examples that we've been doing, okay? All right, so let's take a look first off at the instructions and the notation that's written in the instructions, okay? It says use the figure to the right, and then it has all this stuff right here, okay? We need to be able to understand what these things are telling us. So see here how it has like letter A and then these two lines and letter B. What that says is it says line A is parallel to line B. It's telling us that the two lines are parallel to each other. Okay? So when you see like two letters here separated in the middle with two little lines, that means that it's just telling you in the diagram line A and line B are parallel. Okay? So what does this one say right here? Line P is parallel to line Q. Does that make sense? Okay? All right. So because these two lines are parallel, I can mark them parallel. So do you guys remember the symbol is these little triangles that mean that the two lines are parallel? So everyone draw on your note sheet that those two lines are parallel. Okay? And now we also were told that line P is parallel to line Q, so I'm going to mark these ones parallel to each other. Now, if I just mark them with one mark, that means they're parallel to each other and that they're also parallel to these. So I don't want to just make one mark. I actually want to make two markings to show that these ones are parallel just to each other, not necessarily to A and B. Does that make sense there? Okay. All right, so now that I've got my lines marked parallel, now what I'm going to do is look at this information. Okay. So instead of the information being labeled on the diagram like what you guys did in your scavenger hunt yesterday, we have to apply the information in the sentence to the diagram, okay? So it says angle 1 is 3x plus 40. That's this angle right here. And it says angle 3 is 2x plus 70. That's this one right here. It says now find x and state the theorem that you used. Okay, so let's look at the angles that they're talking about, 1 and 3, 1 and 3. And what kind of relationship do those angles have? Okay, they're congruent. Why are they congruent? What type of angle are they? What's the angle type? Are they alternate interior? Alternate exterior? Are they corresponding? Are they vertical angles? What are they? Look at angle 1 and angle 3. Maybe it helps you if I cover up this part that's unnecessary. Corresponding angles, right? Okay, so because they're corresponding, we're allowed to set them equal to each other. So let's go ahead and set up our equation. Okay, that they are equal, and let's solve that. Okay, so I'm going to go ahead and solve that. And so what do we end up getting for our value of x? X equals 30, right? So what we've done so far is we've found the first part of this, okay? All right? So we've found x. Okay, so now it says state the theorem that we used. So this could be a theorem or it could also be a postulate, okay? And so if you guys recall from our yellow sheet that we took a bunch of notes on, we had a bunch of theorems and postulates here, right? And so which one was talking about corresponding angles? This one. So when it says state my theorem, it wasn't actually a theorem that I applied, it was a postulate, but it's called the corresponding angles postulate. So all I'm going to write down is that I used the corresponding angles postulate. Okay? This is my other answer. Okay? So I've now found x, and I've also stated the theorem that I used to help me do that. Okay. Does that make sense, what we're doing right there? Okay. So now let's take a look at example B. Okay? So example B is now saying we have a different situation. We're going to use this same diagram, but now we have different information. So we're going to kind of pretend like we never even did this problem. We have a whole new problem. Okay? All right, so it says if the measure of angle 2 is 4x plus 7 and the measure of angle 3 is 5x minus 13, find the measure of angle 3. Okay? So let's take a look. Where is 2 and where is 3? 2's here, 3's here. Are these two angles, are they even on the same transversal? They're on the same diagram, but this one, angle 2, it's either on A or it's on Q, right? But this one, angle 3, it's on B or it's on P. So they're not even sharing a transversal, okay? So here's what I'm going to do. I'm going to label these onto the diagram and see if I can use some things I know to get some of these measures onto the same transversal, okay? So angle 2 goes right here. It's 4x plus 7, right? Okay, angle 3 is up here. It's 5x minus 13. Now, if the two measures are not on the same transversal, what I want to do is get them onto the same transversal, okay? So how I do that is I either take this one and find another one that it's equal to, or I can take this one and find another angle that it's equal to and label those angles so that then I have measures on the same transversal that I can compare, okay? So, which angle do you guys want to start with? Angle 2 or angle 3? Doesn't matter. 2? Okay. So, let's say I start with angle 2, okay? I can either compare angle 2 to some angles over here, or I can compare angle 2 to some angles over here. Which way do you want to go? Over here by angle 4, or do you guys want to go up here by angle 1? 1? Okay. So, if I'm going to compare it to some angles over here with angle 1, okay, what do I know about angle 2 and angle 1? What kind of angles are they? What kind? Alternate what? Exterior, right? What do we know about alternate exterior angles? They're the they're the same, right? So if they're the same, can I write that this one's also 4x plus 7? Am I allowed to do that? Okay. All right. So now that I've related these two, okay, let's see if now I can somehow make a relationship between these two. Okay? Because now, are these two now on the same transversal? Yeah. So what relationship do angle 1 and angle 3 have? Corresponding. Good, right? If I drew my box here and my box here, wouldn't they both be in the upper left-hand corner? What do you guys know about corresponding angles? Let's try again. Okay. What do we know about corresponding angles? Corresponding angles are congruent, okay? So if these are congruent, what can I do with their measures? Make them equal, okay? So let's set up an equation making them equal. Okay, so now let's go ahead and solve. Okay, so I've found that x equals 20. Try again. Okay. All right, so now that I've got 20, is 20 my answer?
No.
Look at what the question was telling me to do. Find the measure of angle 3. So is this the actual answer? No. Okay, what do I need to do? I need to take this and plug it into angle 3, right? What is the measure of angle 3 saying that it is? So 5 times 20 minus 13, right? Okay, so what is the measure of angle 3 then?
87.
Okay, good. So it's 87 degrees. Now, don't forget your degree symbol. This is actually one of the answers, right? 20 is not. That's 87 is. Okay? All right. So now from there, what are the theorems that I used here? Well, I actually used a couple, right? Remember when I copied this onto here? What was my reason why? What kind of angles were these? They were congruent, but why were they congruent? What angle type were they? What were they? Alternate exterior. So I used the alternate exterior angles theorem to support doing that, right? So that is one of my theorems I used. Oops. Rewrite this. Alternate exterior angles theorem. Okay, that's how I was able to copy this one onto here, right? Now, what did I do? What theorem did I use when I compared these two? Corresponding, and what was it? Actually not a theorem, it's corresponding angles postulate, okay? So, it is the corresponding angles postulate. Okay? And so these are my two theorems or postulates that I use to help me. Okay, does that make sense why I have two there instead of one? Because I had to do that extra step on that one. Okay? All right. Okay, let's take a look at the last problem. Okay. All right, this is the last one we're going to do today, problem example number 2. Okay, we're going to go ahead and we're going to use the figure at the right. It tells you that M is parallel to what? N. Okay, so let's go ahead and mark them parallel. Everyone mark them parallel on your page. Okay, it also tells you K is parallel to L. So let's mark those parallel to each other. This one and this one. Okay?
Wait, why can't you put the arrows on the other side?
You can put them over here.
Can you put one set on the right, one set on the left, or that'll be wrong?
Usually, typically we see it on the same side. So if you put them here, put them both here. If you put them here, put them both there. But I don't know if it's necessarily wrong if you do them on different sides, but that's just like the mathematicians, they just like to do it that way. Yeah. Okay? All right. Okay, so now let's go ahead and look at the information we have. We have 3 different angles here. Really quickly, there is a typo on this paper, so I need you to change this where it says 3. That is a typo. It is supposed to say 7. Okay, so fix that typo really quickly before we get too far. Okay. This one right here. Okay. Okay, so let's go ahead and label these 3 angles they give me. And then my goal here is to find X and Y. Okay, so let's label these onto the diagram. Angle 5 is right here, so let's call that 2x minus 10. Angle 6 is up here. Let's call that 4 times y minus 25. Okay, and then angle 7 is down here. That is x plus 15. Okay, so now, what do you guys want to solve for first? X or y? Because I want us to find both of them. Okay, why should I solve for x first?
Because it's first in the alphabet.
It is first in the alphabet, but that's not necessarily why I need to solve for it first. Okay? Okay, the reason why I'm going to solve for x first here is because if I have two angles I'm comparing, say I compare this one and this one, then I end up with an equation with an x and a y in it. Can I solve an equation with an x and a y in it? No, okay? But at least if I compare these, they both have x's, and I can solve an equation there, right? Okay, so let's compare these first, okay? I'm going to cover up the unnecessary part right now. Here are your parallel lines. Are they both inside? No. Are they both outside? No. This one's inside. This one's outside. So what does that mean usually if one is inside and one is outside? Corresponding, okay? So, remember, if I were to draw like a box here and a box here, these are both in the same position in the box, right? Okay, so what do we know about corresponding angles? They are congruent, okay? So, we're going to make them equal to each other, okay? All right, so now that I've made them equal to each other, let's go ahead and solve this. Okay, so now at least we've solved for x. Does that make sense how we solve for x there? Okay, now I want to solve for y, but it's looking like if I'm going to solve for y, y is on this transversal right here. I'm going to have to compare it with this angle. And remember how we talked about by comparing these, we don't want to have an x and a y in the same equation, right? So what could I do so I don't have an x and a y in the equation? Yeah, let's plug x back in, right? So we're going to substitute that value there. So 2 times 25 is 50, and 50 minus 10 is what?
40.
So this whole angle here, I can really replace it and say it's how many degrees? 40 degrees. Does that make sense why we did that? Okay. So now, when I'm comparing angle 5 and angle 6, what angle type are they? I want you to think about, are they corresponding? Are they alternate interior? Are they consecutive interior? Are they alternate exterior? Now remember, your parallel lines are right here, right? These two. Okay, so are they inside the lines? No. Are they outside the lines? Are they same side or are they alternate sides? Alternate. So that means they are alternate exterior, right? What do we know about alternate exterior angles from our theorems? They are what? Congruent, right? So I'm going to set this equal to this, okay? So I'm going to do a little bit of scratch work over here. 4 times y minus 25 is equal to 40. And now I'm going to solve this. Okay. So what property do I need to apply first? Distributive. Okay, so 4y minus 100 equals 40. Okay, now what next? Add. And last, what shall I do? Now, when I divide, that does go in evenly. Did anyone get the answer yet? 35? Okay. So now I found x and I found y, right? Okay, the last thing I need to do here is state the theorems that I used. Okay? So what theorems did I use when I was finding x? What kind of angles did we say they were? Let's talk about when I was solving for x. These ones. What kind of angles did I say these were? Corresponding. So that was the corresponding angles postulate that we used, right? Okay, that was one of them. Okay, what was the other one that I used when I solved here? Alternate exterior. Angles theorem. Okay, so that's the other part of my answer. So here I have three things, this, and that. Okay? All right, does that make sense what we did there?